Okay, let's take a look at the answers for page 398. Okay, we can do this. Oh no, I'm coming apart. I got a problem. This is not going to work. This is not going to work. So much for safety. Just make sure you don't cough on me, please. And don't touch me. Keep your social distance. Okay. All right, that feels better. So, yeah, we're looking at page 398. Starting at number 44. We are to show at least two cycles of this thing. We're looking at y equals 3 sine of x. Y equals 3 sine of x. All right, we know what sine looks like. Sine starts at 0, 0. Unlike cosine, remember cosine starts at 1. Sine starts at 0. So for 3 sine of x, starting here, we want one complete cycle in the space of 2 pi. How do we know it's 2 pi? Well, just from experience, we know sine of x has a period of 2 pi. What about using this definition that the period equals 2 pi over omega? What's omega? Yes, it's been a while since we've seen this. Omega is the coefficient of x. Omega sits right there. It's the invisible 1 in this case. So the period must be 2 pi divided by omega, or 2 pi divided by 1, which is just 2 pi. So this thing has a period of 2 pi, ordinary sine function. But it has a an amplitude of 3. So it's going to start here. It's going to go as high as 3. It's going to go as low as -3. And it has to fit one complete cycle in the space of 2 pi. Which means it needs to pass through 1 pi. And it must have a maximum point at 1/2 pi. I'll call that pi over 2. And at 3 pi over 2. So what's it look like? From here to there, down through here, to there, and back up here again. Now the book does specify that you're to show 2 cycles at least. So I could show 2 cycles by going this direction, and then perhaps this direction. Now I've shown 2 cycles. Or I could have done 2 cycles over here, or I could have done as many cycles as I wanted to, as long as you followed the instructions and showed at least 2 full cycles. 1, 2. All right, let's go to number 46. Y equals -3 cosine of x. -3 cosine of x. Okay, same story, but watch out. Same story, not really. Cosine starts down, well, up here rather. But it has an amplitude of 3. And the negative says it's going to be upside down. So instead of starting at 3, it'll start at -3. And it'll go as high as +3. So it's going to look like what? Oh, and it has to have a period of 2 pi. So here's 1 pi, here's 2 pi. So it's going to look like this. There's 1 cycle. What's meant by 1 cycle? Well, I started here at -3. I end up back at -3. That's 1 complete cycle. And then to do a second cycle, do it again. Now, I'm not using graph paper here, by the way, and I noticed some of you have been submitting these assignments that are on ordinary notebook paper. I really want graph paper. Use real graph paper. I know I'm not using real graph paper here. I think it's a little bit quicker and simpler if I just do it like this. Well, Mr. Peer, we feel the same way. It's easier without the graph paper. I want graph paper. Thank you. All right. That's that. Number 48. I hope I'm not making any silly mistakes because I am not taking time to look at the answers in the back of the book. This one says y equals sine of 3x. Oh, that's a little bit different. This one has an amplitude of 1, so it's not going to go any higher than positive 1, it's not going to go any lower than negative 1. It's going to start here, because it's just plain sine. But this time, omega is 3. So the period is 2 pi over omega. So the period is 2 pi over 3. So this thing has one complete cycle between 0 and 2/3 pi. This one's kind of ugly. So this is 2/3 pi. So where is it going to pass through 0 again? Halfway between these two? What's halfway between 2 pi over 3 and 0 and 2 pi over 3? That would be 1 pi over 3. So it's going to pass through right here at half of this. Half of 2 pi over 3 is 1 pi over 3. And it's going to hit halfway between these 2 points. It's going to hit a maximum. And halfway between these two, it's going to hit a minimum. And so it looks kind of like this. Yes, you can check your answers using Desmos, of course. Please do. But do not depend on Desmos to get your answers in the first place, because I will expect you to take the test without Desmos. So will your calculus teacher next year. All right, let's kill that and move on to that was number 48, 50. Y equals cosine of negative 2x. Now remember, from way back, we had a rule: if we lay out the functions, sine, cosine, tangent, and then their reciprocals, reciprocal sine being cosecant, reciprocal cosine being secant, reciprocal tangent being cotangent, you will hopefully recall that we split it up like this. If I have sine of inverse x, or inverse theta, I believe the book uses, inverse x is on all these, or inverse theta is on all these, with sine and tangent, you simply move the negative to the outside. This becomes the same thing as negative sine of x. This one becomes the same thing as negative tangent of x. But for cosine, and its reciprocal, for cosine, you just drop the negative. It just becomes cosine of x. Done. So because this is cosine in the middle section, that reminds me, oh yes, in the middle section we just ignore the sine. So this becomes the same thing as cosine of 2x. We just drop the negative. If you don't remember all that stuff, well, you can hunt down the old video that explains that, and I don't recall which one it was. Find it in the book, and then that'll tell you which section it's in the videos. So, we're actually doing cosine of 2x. What's the period? The period is going to be 2 pi divided by omega, which is 2. This one has a period of pi. So it's going to repeat itself every pi. We'll have one cycle in the space of pi. This is ordinary cosine, which means it has an amplitude of 1, and it starts up here, not down there. So it has a maximum point here, and then it repeats itself when it gets here, so we have another maximum point here. We must have a minimum point halfway between, down here, and then it has to pass through the axis halfway between these two, which would be right about here. I'm just not taking the time right now to get the exact coordinates, although we should. Where is this? If that's pi, and that's 0, this would be at 1/2 pi. And if this is 0 and that's 1/2 pi, where is this? That's 1/4 pi. And this would be 3/4 pi. So what's our curve look like? It looks like that. But we want another cycle, of course. I could go either direction. And there we have 2 cycles. There we have 2.5 cycles. Wow, now we have 3 cycles. So easy. Okay, that was, I don't know what that was. That was number, I've lost it, number 50. Now 52, and this part of the assignment only goes to 54. Okay, so we have y equals 2 times cosine of 1/4 x. 1/4 x. Interesting. Okay. Amplitude is 2. It goes no higher than 2. It goes no lower than -2. Being cosine means it's going to start up here. If it were -2, it would start down there. But being +2, it starts up here. Now t is 1/4. No, it's not. Omega is 1/4. T is 2 pi over omega, which in this case is 2 pi over 1/4. And how do you divide by a fraction? You multiply by its reciprocal. This becomes 8 pi. So this thing repeats itself every 8 pi. It's a whopping wide function. 8 pi. So if it starts up here at a maximum of 2, it has to end up at a maximum of 2. Halfway between, which would be at 4 pi, at 4 pi it has to have a minimum of -2. And then halfway between 0 and 4 pi, in other words at 2 pi, it has to pass through the axis. And at 6 pi, it has to pass through the axis. So our function looks like that. Isn't this fun? And we continue on with a second cycle, or a second and a half, or a third cycle, whatever we want. And number 54, the last one in this set. 54 says we want y equals -4 sine of 1/8 pi. Sine of 1/8 of 1/8 pi. What sine of 1/8 x? Okay, make sure I'm reading this right. Yes. Okay, this time. -4. The negative means it's going to be upside down. It's going to go down, not up. Sine starts here. Let's put 4 here, and we'll put -4 here. Omega is 1/8. So the period is 2 pi over omega, which is going to be 16 pi. This thing's really big, really wide, I should say. It has one cycle in the space of 16 pi. Wow. It starts here. It must end here. It has to pass through the axis again halfway between. So 8 pi would be right about there. It has to have a maximum point. Well, let's see, this one's going to be upside down, so let's talk about the minimum point first. It's going to go downward, so its first minimum point will be halfway between 0 and 8 pi, so at 4 pi, down here. And then at 12 pi, it's going to be up here. And so our curve, notice how they all look the same. They do. They all have the same shape. They are all sinusoidal curves. When you hear about, by the way, in medicine, with heart rates, you hear about normal sinus rhythm. Well, normal sinus rhythm means you have a rhythm. Of course, heartbeats are a little more complex, but it's this kind of it's resembles a sine wave. It's like a sine wave. It's normal sinus rhythm. Has nothing to do with the sinuses, up behind your nose. Okay, that was the last one in that set. Now we jump down to number 68, something a little bit easier. For 68, we want to write the function. It's a sine function, we're told. Amplitude is 2, so y equals 2 sine of something. We're told the period is 4 pi. So the period is 4 pi, which equals, always, 2 pi over omega. So we just solve this for omega. If we multiply by w, divide by 4 pi, the pi's cancel, we're left with 1/2. So the omega value is 1/2, and there we have it. period, we're told is 4 pi, is always 2 pi over omega. We multiplied by omega, we divided by 4 pi, the pi's cancel, we get 1/2 is the value for omega. 1/2 x, don't forget the x. Without the x, it's no longer, it has no variable, it doesn't, we don't graph it. Okay. The next one like that, number 70, amplitude is 4. That's the easy part. Period is 1. Oh, well if the period is 1, which is 2 pi over omega, then multiply by omega, and we see that omega is 2 pi, so it's 4 sine of 2 pi, but folks, don't forget the x. 2 pi x. Without the x, this thing becomes meaningless. Number 72, we look at the graph. I will refer you to the book. I'm not going to draw the graphs up here. Number 72 has a magnitude of 4. It is signed. It passes through 0, 0, so it is signed. It goes upward, so it's a positive 4. Y equals positive 4. Now, it repeats itself in the space of 8 pi. Hey, we've seen this before. So we know that the period is 8 pi. But we also know the period is equal to 2 pi over omega. So we need to solve for omega. Multiply by omega. Divide by 8 pi. The pi's cancel. We have 1/4. So we have 4 sine of 1/4 x. By the way, those parentheses are important. Without the parentheses, we would have 4 sine of 1/4, and that would mean take the whole thing and multiply by x, which is not what we mean at all. Not at all what we mean. Those parentheses are vitally important. All right. Moving on. I'm sure if I've made any careless mistakes along the way, since I'm not checking my answers, I'm sure that somebody will email me, and I'll have to produce a retraction. Number 74. 74 is upside down. It passed through 0, 0, so it's still sine, but it's upside down, so it's going to be negative something. Okay, what's the amplitude? Amplitude is 2, so it's negative 2 sine of, and the only remaining problem is to find out the value of omega. All right, this thing repeats itself every 4, just plain 4, not 4 pi, just 4. So the period is 4, which is 2 pi over omega. Solving for omega, multiply by omega, divide by 4. Omega is 2 pi over 4, otherwise known as 1/2 pi, otherwise known as pi over 2. There it is. Number 76. We have what looks like an ugly one, but it's not nearly as bad as it looks. You can deal with this. It's going to be cosine this time because it does not start at 0, 0. It's going to be cosine. But it's also upside down. It's not starting up here, it's starting down there. So it's going to be negative, and what is the amplitude? 5/2. Negative 5/2 cosine, because it starts down here at negative 5/2. Negative cosine of what times x? We've got to get the period. Well, this thing repeats itself. Where does it hit negative 5/2 again? It hits it at 2. So we have a period of 2. It goes from here and goes back where it started when it gets to 2. So the period is 2, which is, as always, 2 pi over omega. Multiply by omega, divide by 2, we get omega equals pi. Wasn't as bad as it looked. It really wasn't. That amplitude was kind of scary, all those fractions, but no big deal. Number 78. 78 is an interesting one. It has an amplitude of pi. It's going to go from pi to negative pi. Negative pi. And it's based on cosine, so it's going to be y equals negative pi times cosine of, and then we just need the period. Well, it repeats itself in the space of 2 pi, so that's just x. We're done. Because the period is 2 pi, which is 2 pi over omega. We just multiply by omega, divide by 2 pi, we get omega equals 1. So that's it, it's just cosine of x. And we don't need parentheses because there's nothing being multiplied here. So we're done. Negative pi cosine of x. Kind of weird, kind of ugly, but that's okay. And that was number 78, which means we're done. So now stay tuned. Watch for the video presentation for section 6.5 coming up to a YouTube channel near you. And that's it for now. See you later.